This week on the BackTable podcast.
They do needle FNA and then they do brushings. I mean, they're taking tons of samples. And I was just like, time out. You know, you can't see the nodule on fluoro, right? I mean, no way. And I was like, how do you know where the nodule is? How do you know you're even in it? And he's like, man, he said, we don't. We've got our navigation. We trust it. You know, we trust the navigation on the system. I said, what are your diagnostic rates? He's like, well, they hover around 70% or so. I was like, oh my gosh. I said, if a radiologist had a diagnostic rate of 70%, I'm pretty sure referrals would stop probably right then and there. So, you know, it was sacrilege for a radiologist. And I just said, look, don't you guys have any 3D imaging available to you or contrast in the lungs? You know, we use it in the blood vessels. Maybe you guys have something in the lungs. It was just dumb questions, you know, I was asking, but he said no. And I was like, okay, to us, there's only one way to do a lung biopsy, and that's using CT guidance. You got to know your needle's in the target before you start doing your biopsies.
Hello, everyone, and welcome to the BackTable podcast, your source for all things interventional and endovascular. You can find all previous episodes of our podcast on iTunes, Spotify, and on BackTable.com. First, a brief message from our sponsor. RadPad was developed by physicians for physicians. Clinically proven radiation protection during cine and digital subtraction angiography. Don't bet your career or your health on anything less. Trust RadPad radiation protection shields for all your fluoro-guided interventions. See radpad.com for more information and contact info@radpad.com for a free radiation evaluation and a no-brainer radiation protection cap. And don't forget to tell them that you heard about it on the BackTable podcast. Now, back to the episode. Today we've got a very special episode on the origin story of Pulmera, a medtech company focused on revolutionizing the field of bronchoscopic lung cancer diagnosis. They are developing a novel technology to help physicians easily diagnose these lung nodules. Welcome my good friend and longtime colleague, going back
a long time.
About a dozen years. Yeah, Bryan Hartley, welcome to the show.
Thanks, Aaron.
Welcome to your show.
Thanks. Great to be here on the other side of the mic.
So before we jump in, just a little background on Hartley and I. Hartley, when I did fellowship at Vanderbilt, some of the audience has heard this, but I like to retell it. But when I was a Vanderbilt fellow alongside Robbie Morrison, walk-in first day of fellowship, who do I get introduced to? My second year resident at Vanderbilt, Bryan Hartley.
It was all downhill from there.
Exactly. And we both had big wide eyes because I think you were super interested in IR. Obviously, I was super interested in IR, but was not familiar with the Vanderbilt ecosystem. So I owe it to you for kind of holding my hand and showing me around this first few, probably because you were on rotation for like 6 weeks.
6 weeks, yeah.
Yeah. So, I mean, when I forgot my keys at work, you brought them to me. You're very nice. So I appreciate that. And then when it came time to launch BackTable, one of the first people I pitched it to was Bryan Hartley because at the time I think you were at the Stanford Biodesign fellowship.
Yep, about to go there.
Yes, yeah. And so that's kind of my segue to get into your background and introduction. Just tell the audience a little bit about your background and what you did with Stanford Biodesign, and then we'll get into Pulmera.
Yeah, thanks, Aaron. So as you mentioned, was at Vandy. I did med school residency for radiology and then IR fellowship there as well. Always super interested in devices, wanted to know how they were developed, what was a physician's role in developing devices and bringing it to market. So I heard about the Stanford Biodesign program and was fortunate enough to be able to attend after I finished fellowship. So I actually practiced for 1 year at Vandy and then went out there. And that was, it was a big leap. I didn't practice any medicine for that year, and that was my second year out of fellowship, which not a lot of docs do, but it was important to me to be able to chase this lead down, a passion of mine. And so went to Stanford to do the Biodesign Fellowship. There were 12 fellows, 6 docs, 6 engineers, put on teams of 4. And we just went through the whole idea behind Biodesign is to really understand the clinical need that you're going after before you start inventing. So what's the market size? Would people actually pay for it if you solved it? And is there a there? And that's kind of how the magic happens. And how the sausage is made, so to speak. So it was a bit of a life transformation for me.
Yeah, at the time, I remember I'd never heard of it before, but it sounded amazing. And I think you were trying to figure out whether or not you wanted to practice IR.
Yep.
You and I know this because we've had a number of physician entrepreneurs on the show that have talked about, starting their company and leaving medicine versus kind of having one foot in, and it's sort of tricky. And we did kind of go into detail that with on that when we did the episode 30 with you, me, and Eric Gantworker. Where you gave us a little bit more background and some more, we did a deeper dive into that program. So for the audience who's interested in learning more about the Stanford Biodesign program, check out episode number 1 where we had Todd Britton on the show talking about the program as well. I know he was a big mentor of yours.
For sure.
So tell us about because Pulmera came out of the Stanford Biodesign program,
it
right?
Did.
So talk to us about how, how that started, within the program, and then how I assume you and Harmeet, your co-founder, kind of brought that out and developed it further. Can you tell us a bit about that?
So I mentioned before, Biodesign, a core principle, you got to learn as much about the clinical need before trying to invent something. So that includes direct observation in the hospital. So you want to go and watch everybody who's involved in delivery of care, whether it's physicians, nurses, techs, everybody, the patient, of course, obviously. You want to watch procedures. And for us, because I was an IR, we focused a lot on IR needs in interventional radiology and radiology in general. And one of those was we looked at pneumothorax rates during CT-guided lung biopsies. It's a common need. It's always there. But that's what we were going after. And I heard that pulmonologists, I didn't know a lot about what they did, but I knew they did bronchoscopic lung biopsies as well, kind of coming from the other direction than we do, rather than percutaneous. And I knew they had a low rate of pneumothorax. So I said, you know what, I want to go see one of these procedures. So I just cold emailed Harmeet Bedi, a pulmonologist at Stanford. And I said, hey, can I come watch one of your procedures? He said, sure, come on in. So went in and we watched a navigation bronchoscopy where they have their mobile C-arm there, but it's really just for, the time of the biopsy. They will take a pre-op CT. They will segment out the critical structures, or the software will, of this navigation bronchoscopy software. They will then register it to the patient during the procedure. And so while they're navigating their bronchoscope throughout the airways, they're basically chasing a green ball down on this virtual environment that has the CT overlaid. And I was watching as he was moving towards this green ball. And basically when the software says you've reached your target, almost like driving your car, GPS, or using Google Maps, they then will switch, turn on fluoro, and start, taking biopsies. And I watched as his needle, I kid you not, it was like a blast radius zone of biopsy that was like an entire segment of lung. He was just going in every direction, 360 degrees around. And he would turn fluoro on, but it was in one plane. As every radiologist knows, one view is no view. You had no idea how deep he was going or how shallow he was going.
What size needle?
What's that? The biopsy needle. So they were using an FNA needle. So they do FNA. They don't have a core biopsy gun to go through the scope. That long distance, it's all floppy. So they don't have a core biopsy device. They use forceps, though. They use almost like these little alligator forceps, these tiny forceps. And I guess they're the endoscopy forceps. And they'll go in and just take huge chunks of tissue. So during the biopsy, they'll do...
Seems like it would bleed a lot.
Absolutely. And they're taking tons of these like chunks of tissue. You'll see the lung like grip and like pull away from the pleura. They do needle FNA and then they do brushings. And I mean, they're taking tons of samples. And I was just like, I said, time out. I said, how do you, you can't see the nodule on fluoro, right? I mean, no way. And I was like, how do you know where the nodule is? How do you know you're even in it? And he's like, man, he said, we don't. We've got our navigation. We trust it. We trust the navigation on the system. I said, what are your diagnostic rates? He's like, well, they hover around 70% or so. I was like, oh my gosh. I said, if a radiologist had a diagnostic rate of 70%, I'm pretty sure referrals would stop probably right there, then and there. So, it was sacrilege for a radiologist. And I just said, look, don't you guys have any 3D imaging available to you or contrast in the lungs? We use it in the blood vessels. Maybe you guys have something in the lungs. It was just dumb questions, I was asking, but He said no. And I was like, okay, to us, there's only one way to do a lung biopsy, and that's using CT guidance. You got to know your needle's in the target before you start doing your biopsies. So that really explained why their biopsy diagnostic rates were so low. And you might wonder, why do these guys even do biopsies, versus what a radiologist would do? But interestingly, they have a lot of advantages besides just the pneumothorax rate being, less than 2%, because very rarely do they violate the pleura. I mean, it does happen. But they can also sample the mediastinal lymph nodes at the same time. So if they get a positive malignancy, they'll just go ahead and stage the cancer in the chest by biopsying those lymph nodes. And that's something that if we do a biopsy and, it's malignant, they still have to go to a pulmonologist to get a second procedure. So there are some significant advantages to a pulmonologist doing it. But that biopsy rate, that diagnostic rate being so low is the thing that really tips the scales back towards radiologists doing it. You want to make sure you get a diagnosis.
So a couple of things on that, Harley. That's enlightening. I realized, I always knew kind of like they were in the neighborhood.
Totally.
Yeah. I didn't realize their diagnostic yield was that low. I mean, that's like a third of patients are not getting
100%. And it's something that's been even lower than that in the past. I think they have studies like the Acquire study that are, some of them show in the 40%. But they definitely come up with navigation bronchoscopy, and they continue to come up now with robotics like Auris and Intuitive. They're still hovering around the 75 to 80% range. And if you're doing a high volume, that's a lot of patients who are going to go home, empty-handed without a diagnosis.
And going through a procedure like that, which is not, it's pretty invasive.
Oh, yeah, they're intubated.
Exactly. And what's the rate compared to, what's the CT guided rate?
We're 90s plus, 90s plus. That's just, I think, what you could take to the bank is that if you put your needle in a target that you can see on CT, there's going to be some times where maybe you're not in the part that has the cells you're looking for, right? Or necrotic or whatever. We've all been there where you keep sending material to the pathologist or the histopath, and they're like, you're doing rows right then, right? And they're like, not adequate. You're getting frustrated. That just happens. But the best thing we can do, to reduce that risk is make sure your needle is in that target before you start, destroying the tissue around there with biopsies.
Yeah. It's funny. I don't know if you listened to the episode with Chris Beck. And for the audience, there's an episode where Chris has a pathologist on, and he talks about how sometimes a radiologist will come to, or even basically any doc will say, hey, he'll say it's non-diagnostic, and they'll say, well, the needle was in the lesion. They're adamant that the needle was in the lesion. And he's like, I hear you, but the lesion is not in the needle.
I've heard that too. Yeah. It's like lesion and tool and so tool funny. And lesion.
Yeah. Exactly.
I think that's always going to be there. So I think that's going to be the 10% of cases we're going to argue about, right? And that's, I'm sure there are other technologies coming out to, all those looking at fluorescence to making sure you're in the right area.
Yeah.
That's for a different day. Let's do the 80-20. And that's what Pulmera is trying to do.
Right.
Let's get these docs the equipment they need that we know exists, in a way that isn't so expensive that, it's prohibitive,
So to recap, the pain point that you're trying to solve for is basically this diagnostic yield that is not up to par. It could be way better.
That's 100% right.
Okay.
And it's because, again, pulmonologists, they have some advantages there, and that is low pneumo rate. They get to stage the malignancy if it is malignant, all in the same procedure. But the only thing that has kept it out of balance and, really actually kept it in balance between, the two procedures is the diagnostic rate. So, that's what we saw. We were like, look, let's combine the best of both worlds. Let's combine the imaging techniques that radiologists and interventional radiologists use on a daily basis with some of those endoscopy techniques. And I think that really kind of opened up the door for us to start exploring what are potential solutions. Can we use contrast? And we went down this whole road of using contrast, everything else. In the end, we had an answer. It is CT, right? It is just the gold standard. And so, you're probably wondering, like, is there a solution out there that does this? Everybody knows there's cone beam CT machines, and well, let me start at least and tell you what the product is.
Yeah.
Before we get too deep into it. So we know the clinical need we're addressing. We know what we're trying to do. The idea is we are retrofitting simple fluoro C-arms like your GE 9800 or GE 9900 to turn them into cone beam CT-like scanners. So it's a straightforward modification, easily reversible in seconds, and it just gives you those advanced imaging techniques like 3D imaging, augmented fluoroscopy, just really neat tools that are generally owned by super expensive pieces of equipment. Like a mobile cone beam CT right now is like $500K if you want to buy one of those machines plus the expensive annual service contracts. I mean, that's in today's cost-constrained world, there are very few docs that are going to go out and buy one of those. They can justify the economics of going out and buying one of those. You have to get a return on investment somewhere. So what Pulmera is doing is we're just taking the machine you already have, retrofitting it for a very low price. I mean, we're talking 1/10 the price. Basically, what we're doing is trying to target the annual service fee of the bigger machines, and you pay that annually rather than outputting that giant capital cost up front. We're retrofitting your machine for basically the service price each year.
Okay. And is it hardware, software, a combination of both?
Yeah, great question. It's both. So we have some hardware components. We have some stabilization, because what we're doing, we're not putting a robot on this thing. That's what makes them super expensive. You are manually rotating this thing around, and then we reconstruct the images using our proprietary algorithm. And that's really why no one's been able to do this. People have been trying to do this for decades. And the easiest solution everybody finds is build a new machine that has a robot in it that rotates it around. Because as everybody knows, CTs, you have to be very precise with your image acquisition. And that does not really translate to manually rotating one of these workhorse GE, 98, 9900s. So we have to do a lot of math and, core algorithm work to make our images come out clean. And we're proud of what we've done.
That was my next question, is how good is the image quality compared to a CT scanner or even, these fixed units with CT fluoro?
Yeah, I think we are as good as a lot of the mobile cone beam CT products and, a GE OEC 3D or Siemens CIOS. I think we can reach their image quality, and we offer some things that, maybe they don't have. Augmented fluoroscopy is something we're going to come out with standard. So, you can segment a structure on your CT scan and then overlay it as like a virtual overlay onto live fluoro. So, if you're doing a biopsy, you're going to adjust your needle based off of where that little virtual nodule is on fluoro.
Ah, very cool. That term augmented fluoroscopy is interesting.
Like augmented reality,
but
right? I guess that's
right. But it's an overlay. Correct. Though, but it doesn't require like special glasses.
Nope. So you're using the spatial information from the CT scan, and as long as your scanner doesn't move, like as you don't roll your C-arm around, you can spin it around, but as long as you don't roll it around, then you're going to get a projection of the target. Say it's a pulmonary nodule coming up on live fluoro, and that's just to help you redirect your needle in real time.
Okay. For the so this is a patient undergoing bronchoscopy, which normally is done under fluoro in addition to direct visualization, but then you're applying this, basically the CT imaging, cone beam CT imaging, using your hardware and software, and the software you say is proprietary that comes with the package. Okay.
That's right. And,
cool.
I just want to be clear also, this is not just for pulmonary. That's really our beachhead market. But as you can imagine, like you're a radiologist, you're an IR, you're thinking right now, how could I use this in my practice? Is there anywhere that you would want to use this? And there's lots of specialties out there that are starting to use 3D. Traditionally, it's owned by radiologists. That's a technique that we train in. But now you're looking at orthopedic surgeons doing posterior spinal fusion, placing those rods and screws. They're starting to use 3D. So it's really more of a platform technology. Our vision is to provide 3D imaging for all, right? We want everybody to have 3D imaging available in their OR, endoscopy suite, or IR suite. And we don't want it to cost an arm and a leg where you have to haggle with administration, to get this, because we all know having some form of 3D imaging is going to be better than not for patient care. Your outcomes are just going to be better.
Yeah, I mean, that's, so your beachhead target market is pulmonologists performing procedures. But that being said, there's a lot of embolization procedures out there where it'd be really nice to have, cone beam CT on 100%. The go, like in a flexible way in an OBL, for example, like, prostates, genicular artery embolizations, those sorts of things.
100%. Yeah, I think the sky's the limit. I think where 3D, like you said, in OBLs, because every IR's got access to this probably at their main institution. But really in some of those OBLs, maybe they don't have, a fixed system. Maybe they do some clinic work. Maybe there's pain management folks who may want to use it. So, the sky's the limit. And we just want to make sure that everybody that wants 3D imaging can get access to it, in a cost-effective way.
Right. Yeah, no, I mean, it sounds very cost-effective because these fixed units are crazy expensive.
Expensive.
Yeah, and as we know, most people, especially, GI procedures, pulmonary procedures, IR procedures are largely done under fluoroscopy, and having a portable unit is, it's just space efficient, it's cost efficient, especially people who are just starting out. Maybe they upgrade down the line but it's cost prohibitive.
It is
to, like you were saying.
Like how do you justify the unit economics, right? That's just hard to do in your practice, but maybe having some 3D imaging could potentially unlock some procedures. I was talking to a radiologist not too long ago, says I'd love to have something like cone beam CT where I'm doing biopsies. He's like, I don't do lung biopsies where I am. And so I don't get the referrals from hospitals because that's just a necessity for this local hospital that you need to be able to do that. And he was like, I would love to be able to do that, but I need access to some form of CT.
Yeah. So quick question, why haven't others been able to pull this off with like this portable unit? And or are there existing options, other solutions out there that are kind of direct competition?
Yeah, great question. There are. You have GE, I mentioned it a little bit earlier, GE 3D and Siemens Cios. Those are your robotically rotated machines. So that's a big capital piece of equipment. The thing is a behemoth. I mean, they're big, first off. They're expensive. And, they're cost prohibitive is what I would say. And so that's how, if you're going to do this, if you're going to have a portable CT scanner, that's what's been done. But I think really it's limited the market, and what we've tried to do is meet the market where it is. Everybody has a mobile C-arm that can be manually rotated around. And I think the real art to this, the unique aspect, is being able to manually rotate this thing around, even with all the bumps and bends and, torques. I mean, these machines aren't precision CT scanners, right? So rotating it around, people are going to go slower, faster. We have to take all of that into account, and that builds into our proprietary algorithm. But we also have a proprietary stabilization system that we put on that can be taken on and off in a matter of seconds. And then we put it on, and then it just allows for a nice, smooth rotation. And we've got 4 patents. Yeah, we've got 4 patents around that. So we really have a combined intellectual property strategy of patents plus trade secrets, which really comes in our algorithm. And that's what helps us protect ourselves.
Yeah, very cool. And how close are you guys to being commercial?
We are about 1 year away. So we plan to submit FDA clearance at the end of this year. And then soon after clearance, we're going to do a pilot launch and get this in the hands of some folks to try it out.
Ah, very cool. What have been the big challenges along the way? You guys have been working on this for some years, right? So what were the big ones?
I think the biggest challenge at the beginning was, first we said, hey, can we get some 3D images with this machine just by rotating it around? And what we found was our image quality was terrible at the beginning because, and this is only after we figured this out, the giant detector head, it's an image intensifier, and that's the big round, detector. That thing weighs a ton. And so as you're rotating it around, it will vibrate as the weight shifts when you're rotating that thing. So we had to design a stabilization system. And until that happened, our image quality was nowhere near good enough to be able to do a procedure. So the real unlock was stabilizing the machine so that you get a nice, clean, smooth rotation going through. I'd say by far that's probably been our biggest technical challenge. I think clinically, you can be dealing with, pulmonologists have never used, if you're going to start with a beachhead of pulmonologists, they've never used CT before. They're just now starting to dabble in CT. And convincing folks to use a piece of equipment like a CT scanner and that it's better, I think mentally that's been challenging, because as any radiologist, I think 100% of radiologists would say, you've got to use CT to do a lung biopsy. Like you can't be in there just playing around, not knowing where your nodule is, right? You wouldn't do that. I mean, what if you were 1 centimeter away from your nodule and you're just taking biopsies all over the place? I mean, it's just, obviously it's not the way to go. But I think it can be tough trying to communicate that to specialties that maybe haven't used CT before, and trying to say, hey, this is the gold standard. This is not, it's not an argument. It's not really something this is something that was settled 20 years ago or more, But I think you got to be able to see where you're going. And I think everybody would agree on that. You would think so. But I think there's still some of this, momentum, let's call it. There's momentum in the field that says maybe you don't necessarily have to have it. But I think a lot of that is it's the cost. I think that's a barrier that's been put in their way to utilizing this. And I think at that point, once you have a barrier in your way, you're like, I can't get it anyway. Do I really need it? But once a lot of these folks have it, they're saying, I'll never go back. Harmeet, my co-founder, who definitely couldn't have done this without him, he's critical. He's really a key leader in doing this. And I'll tell you, his lung nodule volume has gone from 44 a year over the next 3 years. He's now up to over 450 lung biopsies a year.
Oh my God, the 10x increase in lung biopsies, it's incredible.
That's right. And it's because he's getting access to some CT. And he's like, well, these nodules that I would have just held in reserve and maybe watched them get another CT scan 6 months later, he goes, I'm getting the confidence to go after them. These 9 millimeter nodules, 10 millimeter nodules, because he can hit those targets now. He's saying, I'm not going to make these patients wait. And I know that makes the patients feel better too, to know whether they, what they have, rather than just saying, hey, do I have this ticking time bomb inside of me?
Yeah. So, I mean, that's another question. So you're talking about a 10x increase in that procedure.
Correct.
Just on the lines of the economics of this procedure, what are, because I know the CT guided biopsies that we do, it's not a huge amount.
Yep.
But if you streamline it as part of your practice and these patients are low risk for pneumothorax, I think that's a big difference. Yep. So can you tell us a little bit about that on the pulmonary side?
Yeah, so the unit economics are fairly favorable. So I think Medicare reimburses, assuming they do mediastinal staging, they have to sample 3 lymph nodes, I think. I think their bundled code is around $7,000.
That's incredible.
Right. Now, granted, they have to do, a lot of times they're intubating and they maybe it's more involved a little bit, but that is Medicare. Right. That's Medicare reimbursement rate. Yeah. So you can imagine that, private insurance maybe double that. Maybe depending on where you live, maybe a little bit more. Like in California where he lives, it's more. They say it's triple. So you are talking about significant volume increases that can drive income, revenue, so to speak, but also the downstream. I mean, you're catching these patients early that have, now before maybe they would be a little bit higher stage with lung cancer screening coming out, and now people getting biopsied earlier, you're getting more stage 1s. And so when he's driving those diagnoses, he's sending that workflow or that patient flow to the hospital for radiation, segmentectomies,
other treatment,
chemo or whatever. And these are downstream drivers of revenue for the hospital too. So as far as aligning economics, it's a win for the patient, number one, because they get their diagnosis earlier, whereas before maybe they would have waited, right? And then next you're increasing your revenue, and then number 3, the hospital gets downstream revenue as well.
Very cool, very cool. And so, hey, tell us about the team real quick. You mentioned Harmeet again. So he was your co-founder. Any other co-founders or who's on the team?
Yeah, so Harmeet and Harmeet is chief medical advisor, co-founder. He's at Stanford. Our offices are based in Redwood City, out in California. We got two guys leading our technical charge. Our CTO is Nicolas Robert. He and Rex Kerr came from J&J Oris. So they worked in a robotics company before, and they are just absolute superstars on the technical side. And that's who's banging away right now and working on our regulatory submission. We have a ton of other consultants. We worked with Norbert Pelk, who is just a absolute famous superstar in the world of imaging, worked on some of the first MRIs, and he was our first advisor out of Stanford. And we got a great team, and we're pushing through. The goal is to get to FDA clearance ASAP, get out to that pilot launch, and get this into the hands of some docs.
Yeah, and you mentioned you're about to raise some money. Can you tell us a little about that?
So we're opening this round up to outside investors. We're raising $1 million right now total. That's to get us through FDA clearance. We have about, I'd say, $500 to $700K committed, so we can take the difference before we're capped out. And we wanted to open this up to the BackTable community. We know it's a special group of folks, includes a lot of IRs and surgeons that naturally understand what we're trying to accomplish. And that's a large part of who we want to partner with, are the folks who would use it. This is a lot like BackTable. It's made by physicians for physicians, right? And we feel like this product, it fits that mold very well.
Yeah, well, as a physician investor, the key question I always want to know is what's the minimum?
Oh yeah, check size. What's the minimum check size?
Yeah.
So we're looking to target minimum check sizes of 25,000 to get up there. And so that
good to know.
That's what we're looking for.
Okay.
Yep.
And no maximum.
$1 million. Yeah,
somebody can write a check for
we
me.
already have some money committed. So, but yes, there is no maximum.
Fantastic.
And we're doing an equity financing, so you will actually get shares out of this. This is not like convertible notes or safe notes. We already have an equity financing going on through our attorneys, and you will be issued shares in the company directly at so we're raising it a $5 million valuation right now.
Okay, cool. We need to do an episode on that, on financing, what the difference is between those things. Yep. You know what I mean? Like safe notes, equity financing, like all these terms that for me as a physician investor, unless, I always got to look 100%, it up.
100%, dude. It's taken me years
to kind of dive
and
into it.
There's so many nuances that are so important that I don't know that you find out after you already done it. But what I can do is probably bring in one of my attorneys, or something, just to explain.
That'd be great.
What's a safe note?
Yeah,
what's a convertible note? What's the difference between the two? What's an equity financing? How does dilution work? When you raise another round of investment, how do you get diluted down?
Right. What are the pros of
exactly.
of each? And so
like
forth.
equity financings, what we're doing is expensive. I mean, we'll spend $50K plus $70K to the attorneys to build this thing. But it's much more attractive to everybody because they know exactly what their shares are worth. Like, period. You valued the company. You know, like, it's worth 87 cents a share. Okay, you know that. When you do a safe note or a convertible note, you don't know what it is. You just say, I have an IOU in my hand, and at some point down the road when they do an equity financing, it'll convert into shares, but I don't know what price it'll convert yet. So there's an unknown with convertible notes, but it's much cheaper. You could do it for like $5K or like $10K.
Right. Which is why people
do it. Yeah. And it's super simple. All I got to do is send you a piece of paper, and you just sign it and say, I'm an accredited investor. I sign it and say, here's how much I'm giving, and you get your safe note, and then I get my money.
Yeah. So Bryan, thanks for explaining all that. I guess the next key question is, how can folks get in touch if they're interested in participating in this round?
Awesome. So I would say reach out to me directly. So my email is Bryan, Bryan.Hartley, Hartley @Pulmera.com. Or, of course, you can call myself, 423-432-0612.
Love it.
And I'm happy to discuss. And we're going to have this last funds raised by June 1st. That's our timeline to do this. So please reach out before then.
Well, fantastic, Bryan. Thank you so much for coming on. And again, everybody, that is Bryan with a Y. Yeah. Don't do what I always do and spell with an I.
Happens a lot. Thank you, Aaron, for that.
Yeah. All right, buddy. Thank you so much for coming on.
It was a pleasure.
Thank you to the audience for listening. Thank you so much for listening. If you haven't already, make sure to subscribe, rate the podcast 5 stars, and share with a friend. If you have any questions or comments, direct message us at @_BackTable on Instagram, Twitter, or LinkedIn. BackTable is produced and hosted by myself, Aaron Fritz, and co-hosts
Chris Beck,
Sabine Dong,
Michael Barraza,
and Ali Behetti.
Our audio team is led by Kieran Gannon, with support from
Josh McWhirter,
Aaron Bowles,
Josh Spencer.
Design and Digital Marketing led by Brian Schmitz.
Social Media and PR by Ann Dang,
Manisha Naganathanahali,
and Manbir Singh Sandhu.
Administrative support provided by Jamila Kennebrew.
Intro and extra music is Ripperoo by Skeptic Moon. Find us on Spotify or at local live music venues in New Orleans, Louisiana.
Thanks again for listening.